Hi everyone, my name is Caetano, a second-year PhD student in computer science at UC Santa Barbara. Today, I'm going to share ARLang, an outdoor augmented reality application for Portuguese vocabulary learning, a collaboration with my co-authors Alyssa Lawson, Yimeng and Misha. Most of our daily activities are linked to specific physical spaces, not just indoors, like in labs, offices, or homes, but also to the outdoors, like in parks, campuses, or streets. But on top of the physical space, there's another layer, a virtual layer, that enhances the physical world with metadata like text, geolocation, and computer vision features. Thanks to augmented reality, we can blend these two dimensions and create innovative applications that leverage this powerful interaction. One such application is language learning. In this work, we focus on Portuguese, a language spoken by over 260 million people as either native or second language in 10 countries and territories. Previous research has explored augmented reality as a tool for language learning in outdoor environments. However, there is limited evidence showing the advantages of these methods compared to traditional non-AR techniques. So we ask the question, is learning a new language in outdoor AR more effective and enjoyable? To address this question, we developed a system called ARLang, allowing users to learn Portuguese nouns for objects around them in outdoor spaces. With ARLang, users can see AR tags attached to the physical objects in the outdoor environment. These tags display objects' names in both English and Portuguese. Users can tap on the tags to hear the Portuguese pronunciation. After interacting with a tag, users can continue exploring for more tags in the area, tracking their progress using a counter. To evaluate the effectiveness and enjoyment of ARLang, we conducted a user study involving 44 university students with diverse backgrounds. We collected information about their familiarity with AR technology, demographics, and language background through a pre-study survey. Next, we split participants into two groups. One learned using ARLang, while the other using an alternative flashcard application. Following the learning session, we had participants to engage in a distractor task to avoid rehearsing and empty their working memory. Then participants took a quiz assessing their learning outcomes by answering questions in both Portuguese to English and English to Portuguese translations. Finally, we gathered their feedback on the overall experience with the methods through a post-study survey. Now, let's have a closer look at the experimental procedure. Regardless of their assigned groups, all participants were given the task of learning 20 Portuguese nouns within a 10-minute time limit. The flashcard condition took place in a classroom. Participants used a free web app that allowed them to access digital flashcards displaying Portuguese nouns on the front face and the corresponding English translation on the back face. Participants could also listen to the pronunciation of each noun and see a picture of the object. They were comfortably seated at all times, providing them with a stable and focused learning environment. The AR condition took place in an area of approximately 900 square meters. Within this area, the AR tags were placed on objects of interest along a path of approximately 135 meters. To maintain consistency, all participants started their learning sessions from the same spot. However, once they began, they were free to choose any direction they preferred, as long as they remained within the boundaries of the study area. This allowed for individual exploration and ensured participants had the freedom to engage with AR tags on their own terms. To ensure the safety of the participants and provide assistance if needed, an experimenter accompanied them throughout the AR experience. After compiling all the answers, we asked the two native speakers of each language to mark which answers were in fact acceptable synonyms. This allowed us to assign a score if the participant learned the concept behind the word, but didn't answer exactly how we expected. Instead of just assigning scores for the correct answers and the accepted synonyms, we used the maximum adjusted Lawson score to assign partial credit in case of typos. The Lawson distance between two strings is the number of deletions, insertions, or substitutions required to transform the source string into the target string. For example, let's say the correct answer is A, B, C, D. The accepted synonym is A, B, E, F, and the participant answered -B, E, -. The level distance between A, B, C, D and dash B, E dash is 3, and the adjusted Levenstein score is 0.25. Now the Levenstein distance between A, B, E, F and dash B, E dash is 2, and the adjusted Levenstein score is 0.5. In this case, this answer would score 0.5. Based on learning theories and existing empirical evidences, we expected that integrating language learning with AR in the outdoor settings would positively impact the learning outcomes. However, our results revealed that while users prefer vocabulary learning with outdoor AR over traditional flashcards, we didn't observe significant improvements in short-term recall. We speculate that a combination of technological, subject-related, and environmental factors hindered the learning process for outdoor AR users. The vision-based tracking present in AR platform we used often suffers from drifting in the outdoor spaces due to moving background elements and changes in lighting conditions. Additionally, the interaction based on sound and screen tapping might not be ideal for the outdoor learning setting. Moreover, the outdoor environment posed unique challenges absent in indoor settings. Users had to navigate obstacles constantly to move between tags, and distractions like people walking by, noise, and unexpected events were ever present. Surprisingly, we also discovered that participants expressed concerns about social judgment, feeling as though they were being judged by others as if they were recording videos without permission. Among the subject-related factors, some participants reported having limited familiarity with AR technology, which could have negatively influenced their learning experience. Despite the lack of significant differences in learning outcomes, users of the outdoor AR tool had a significantly more enjoyable experience and reported having fun interacting with the environment through AR. Lastly, we share some design considerations derived from our experience with ARLang. In our work, we manually positioned AR tags in specific locations. However, for large-scale deployments, it's crucial to explore cutting-edge advancements in object recognition to generate vocabulary content. Large language models could also be employed to handle more complex grammar constructs. Another important aspect to consider is providing multimodal content. By adopting this approach, we can offer users a rich blend of visual elements when they are relatively stationary and can focus their visual attention on the learning task. On the other hand, when users are on the move and need to be mindful of their surroundings, incorporating audio content becomes valuable. Furthermore, it is essential to consider the current limitations of visual-based tracking to prevent issues like drifting that can negatively impact the user experience. Fortunately, recent improvements in AR software development kits now allow us to combine GPS readings with visual inertial data, leading to a more stable and reliable tracking. For more details, please refer to the paper and feel free to reach out with more questions. Thanks for watching. Obrigado.